Hi and welcome to another one of the Tech Geeks videos. Today I'm actually going to be doing a TP-Link setup for a customer, so I thought I'd actually video how I approach this and what I do because it's an interesting project. It might be something similar to what you're looking to do, so maybe there's a little bit of gold in there. Now there are many ways to approach this, but hopefully it gives you an idea of how I will, and I'm going to show you the steps of all the equipment that we're using, how it's all plugged together, and ultimately how we then configure it in the software as well. So hopefully that is going to be useful to you. So as we know with TP-Link Omada, there are several ways to control and manage this. Either we need a piece of software, free software that needs to run on a computer in your network. You can have a hardware controller on site. You can have a router with the controller built into it, or you can use the free cloud and paid cloud service. There are several variations because TP-Link is sort of in a little bit of a flux of how that operates at the moment. So we're going to be basing this on an on-site controller, and we're going to be using this. This is a little TP-Link OC200. This is PoE powered, so we're going to have a TP-Link PoE Switch running this to give it power. But this is going to be our brains. This is where we're going to do all of our configuration. And maybe just pop this down here so you can just have a little look at that. So we have our PoE in here. We don't need anything more than that because all of this, it's not a router or anything else. It literally is a software controller. The next part of this is going to be our router. And I've chosen this, which is the EAP610-W4G. Just hold that up there for you. So this is an AX3000 router. It can do a total of about 3,000 megabits a second. Now that's split between the 2.4 and the 5 gigahertz. As you know, with 2.4, we can only get a speed of around about 600 megabits a second. So theoretically, this can do then the rest of it, 2.4 gigabits a second in the 5 gigahertz frequency. That's probably not relevant because I've only got a 100 meg internet connection. But at least we know we've got some future proofing on this. So this is a metal construction. We've got these 4G antennas on either side to give us good reception. We've got our wireless here at the back. Our micro SIM slot is here where we're going to put our 4G SIM in. That can handle up to about 300 megasecond, obviously, but it depends on the service and how close you are to the tower. Our NBN connection is going to go into here, and then we're going to be able to use this because this is in the house. This is then going to go onto our network switch and give us some wireless again within inside our main property. So then inside our main property, obviously our router is going to give us some wireless, and we just want to extend that a little bit further. And so we're going to be using one of these. This is the EAP610. It's a ceiling mount access point that you can see here. It is again PoE powered. So we're going to mount that somewhere else in the house, a little bit further away from the router that we're looking at to give us some good Wi-Fi coverage within inside the house. That will obviously be connected back to our TP-Link switch that's going to be powering it. Then we want to get the connectivity outside. So we're going to be doing two things. And there are two ways of doing this. So we're actually going to be using these two. This is the EAP215 bridge kit. These are able to do point-to-point. So we're going to have one of these on the outside of the house, one of these on the outside of the demountable, the Donga, pointing at each other. That's going to give us our Wi-Fi connectivity down. Now, these can also be outdoor wireless access points, but we're not going to be using that feature because we do have some 2.4 gigahertz cameras the customer has, and these only give outdoor wireless at 5 gigahertz. So it's probably not quite what we're going to be needing. So we're actually also going to mount this an EAP610-Outdoor, which is an outdoor access point. We're going to mount that outside the property to give them really good outside wireless. So we will obviously run from our main router a cable out to one of these. We are actually going to use the spare ports in the bottom of one of these. Maybe you just hold this up to the camera here to run out. So we only have to have one cable out, and that will split out to be able to power our big outdoor access point. And we'll show you how that all cables together in the video as well. So that's going to go on the outer side of the property pointing down to the Donga. Then on our demountable, the Donga, we're going to have another one of these mounted pointing back to the house, and that's going to link our connectivity all the way down to the Donga from the house. And now we've got connectivity down there. What we're going to then do inside that donga, which is the home office, we're going to put one of these. This is an EAP650. Slightly different from the 610s. We're working 650. This is only just newly released, which so excited to be able to use this because I've been waiting for these in the TP-Link range. This is the desktop model. So this is a little desktop device. We have 4 Ethernet ports on this side. So this will be connected to our outside access point or our access point bridge, wired back to this into port 1 over here. If I just hold this down here, maybe port 1 over here, and then that will give us 3 wired Ethernet ports as well as really good wireless 6 coverage from this device as well. And that will give us the end of our chain and give us a Wi-Fi right the way down in the donga there. So we should have given Wi-Fi and sorted that in the house. We should have then been able to connect it to an outside access point and give us good outside coverage, and then extended it all the way down to the donga and given them Wi-Fi inside with this beautiful desktop unit and wired if they want it there as well. So there's going to be quite a few components to join together. I want to show you in due course how that all fits together. But I wanted to show you all of the bits and pieces before we set them on the bench and then show you how they all connect up. So let's get into doing the actual configuration and the wiring, and then we'll show you step by step of how I make this work. Okay, so we have amassed quite a lot, as you can see as we've opened all of the boxes, and I've shown you some of the bits that are here. We are not going to necessarily use all of the pieces from the boxes. For instance, like an access point like this comes with a power pack as well. We're going to be actually probably PoE powering that from our PoE switch here. So I'm going to clear the decks a little bit. We are going to then start building this up as we add each little bit. I've got a power bar over here. I've got a couple of Ethernet cables. This one's going out to the internet, and this one's going out to the computer I'm going to be using to show you all about it. Now, there are lots of different ways to set this up. It's going to be quite a long video. I want to show you speed tests and how to optimize your wireless at the same time. So please do use the chapters in this video. Hopefully you'll be able to find then relevant areas that you want to learn a little bit more about. So let's start to clear a little bit of the area and get some of these bits and pieces plugged in together. So we're going to start, like I said, with our router. Our router is obviously our most important bit, and there are a number of different ways of doing this. We're going to set this up with the router being our controller, and you could set this up with the 4G active to start with. I'm going to set this up with the MBN or our fixed internet connection first, and then we're going to build it on from there and get 4G running a little bit later on. So we're going to take our device. We have got obviously our WAN port on here, multiple LAN ports. So let's get the power plugged in the back here first, this end here. All right, so let's get the power connected up onto here. This unit does take about 3 or 4 minutes to boot, so do be patient till the lights come on permanently. I'm going to plug our WAN connection, our internet connection, in the green port, and then over here I'm going to plug our computer. I'm going to be using a laptop or a computer that I'm going to give you a screen grab from, show you how we get it all set up. I'm going to plug that into the first port there. Now look, like I said, there are a number of ways to set this up, but you will probably find it a lot easier if you start off by using a computer. Once we've got this actually configured, we will join it to the wider TP-Link cloud, so you can manage it from the app from wherever you are. But as a starting point, this is the way we want to actually get this going. So we're going to let that boot, but as it boots, we're going to get a couple of other devices connected to this. We are going to connect up our PoE switch, which we will need to run our little OC controller in a moment. So let me go and grab a couple of cables. I'll be back in a moment when we can start connecting that into place. All right, I knew there'd be something probably that I would end up missing. So I've grabbed a whole load of short cables. You'll probably have longer ones in this instance. So our switch is going to provide power to all of the devices. This has got 4 ports of PoE. It's got 65 watts of power. That's important because each access point or that we're going to be using uses a certain amount of power. So we need to make sure we have enough power allocated from our switch. So these will probably use about 8 watts each. So obviously if we had 4 of those running, we need 32 watts of power. So this has got 65, so we're ample on that. Interesting thing with this is it actually comes with a really large power pack, but that's obviously because of the extra wattage it needs. So let's just get that plugged in as well here to our power board, and we can start that powering up. And we'll now need to actually connect this device here, up to our switch as well. So of course you could have, up to our router, you could have obviously plugged this directly into the switch, and then could have plugged the our laptop or our computer into that. But I will leave this plugged into here. It doesn't really make that much difference. So I'm going to use the non-PoE ports, one of the ones up at this end here, so that we don't waste our PoE ports. And I'm going to plug that now into one of the other spare LAN ports here on our controller. All right, so that has given us some spare network ports. Try and clear these cables out of the way a little bit so that it's still accessible and you can see what's going on. And we should hopefully now start to see that this is starting to power up. The next thing that we're going to need to do on here is we need to power our OC controller. This is not a router, this is literally a control device. It's going to allow us to manage the router and the switch that we've got here and all the other bits and pieces that we've got in this setup. So we need to actually power this from our little switch. So if we take our I'm going to use an orange cable here, we're going to plug that in here to one of the spare PoE ports up at this end. So I'm going to plug that in, and we're going to plug that in here to our Ethernet PoE in port here. And we should then find in a moment, there we go, this has got power. So this is now receiving power from the switch. The switch is connected to our router and then out to the internet. Now, there will be some things that you, in this initial stage, that might not mean that you've got internet access. If your IP address that's on here, so maybe you've connected to Starlink or whatever, this by default has a 192.168.1. IP address, and I'll show you a little bit more about that once we hop onto the computer. So that could mean, because Starlink, for instance, has 192.168.1. Here. So if we plug this directly into Starlink, it'll look like this setup doesn't work. So we're going to be connecting to this and changing the IP range first so that we get everything as it needs to be. But we needed to get this in this initial stage and a computer connected to what we call the LAN side, the local area network, the LAN side of the router, before we could actually get any of that setup done. So those are our main components now set and ready to go. Let's have a little look. We've got all of our lights showing quite comfortably on here. We've got power coming out of this one. Let's have a little look. Our lights here are now on the router. We've got a WAN connection. Both of our local area networks are connected, and our OC200 is started up. So it's probably time that we can now jump onto the computer and start to do some of the configuration. And then we're going to slowly come back and add a little bit more into this setup as we go along. Okay, so let's come to the computer here now. So we're going to do this, like I said, this computer is connected to the LAN port of our TP-Link router, our EAP610 4G router. And obviously the switch is connected and the OC controller is connected. What I first like to do is check that I've got an IP address, check that it doesn't conflict with anything else. Like I said, I will show you in case it does. So I've just gone to Command CMD and hit Enter. I can type a command called ipconfig, and this will show me the IP address. And really what we're looking for is, this is what we call the IP range. So 192.168, and this 0 here is important. By standard, a lot of routers use 192.168.1 in here. For instance, Starlink does. So if the LAN IP address here was 192.168.1.103, then this would look like it wasn't working and wasn't going to connect to the internet, and we would need to change its IP address, which we'll do in a few minutes to show you how you would go in that process. But in this instance, we're all okay, and I know that this won't conflict with what's connected. So we can then choose a command ping 8.8.8.8, which is Google's DNS server, and this shows me I've got internet connection. So that's my starting point in the journey. Now, this default gateway is actually the IP address of the router. So up here, if in the browser, I'm going to put 192.168.0.1. And this is now going to allow the interface for the controller to log in. So in the first thing, we want to set this up. Do make sure you remember what this is going to be. I'm just going to see if it'll allow me. Please enter at least 6 characters using. All right, so let's think of something that I can actually remember. So we can end up doing this over and over again if we're not careful. All right, let's see if that worked. So now we've set this up as our default way to get into the device. I'm not going to save that password, obviously. And so maybe do start this with a fairly simple password. You can always change it later. We are going to need to add this to the controller, so we will need to know what it is. But I just wanted to show you that you can obviously just do this ready and running. I'm not going to do a quick setup because I don't really want to have much done on here. What I want to just show you is we're getting an internet connection here. All right, our 4G modem isn't connected and running because I've not put a SIM in, which we'll do later on. And what I really want to do is I want to be able to find the IP address of the OC controller so we can connect to that as well. So let's have a little look. We've got a few settings that we can do in here. Maybe it's in here, in LAN and DHCP list, because it's going to get an IP address in the same way as you can see. I've got a few devices here already on this network. So here's our OC200 controller and it's on 102. So we're going to use that IP. Like I said, there are lots of different ways of doing this, but I'm going to use this as the way of making this fairly easy to go. So I've now got this IP address and I'm going to put this up in our web browser here. And this will allow us to get access, hopefully, to the OC controller. And that's what's going to actually govern the rest of our network. And once that's installed and running, then we're going to do everything with the Omada controller. So this is our first stage. We're going to log in. It's going to ask us a few questions about getting started. So we're going to get started. I'll just choose agree down here. We're going to just choose administrator name. This is up to you. So I'll put my name in here. Maybe we'll just put our email address in info. There we go. I'm going to put a password in here. I'm actually just making this match the one that I did on the router. Now, we can link this to our TP-Link login. What does this do? This allows us to actually remotely manage this device from the Omada app, from anywhere we are, as long as our OC controller can see actually out to the internet. I'm not going to do that for the moment. I will add that in a little bit later on. I just want to be able to do everything on this side. And if you didn't have internet access for some reason, you wouldn't be able to finish that piece off. So really, we want to just actually do this. I think that we will just call this, actually I'll just call this TTG. All right. So hopefully this will now go through and do a little bit of an essential. And it's going to ask us to do a new config. If you had a backup in your scenario, in my scenario, I don't. I'm going to do a new configuration. So let's call this TTG 4G test. And I'm in Australia, so let's just get this typed in here. And my time zone. All right, let's just see. We're in a +10, I think, depending on how this is listed in here. Brisbane, there we go. I don't want to join the experience team, so we're going to do next. Site name. So this is my location. I'm going to call it Spinal, like we do with most of our videos. And again, Australia. Time zone. This is just, it provisions it with some of the information in the way that we want it to be, but all of this is controllable later on. What is this? This is a home setup device account. So this is the username and password that's going to be given to each device when it's adopted. So that will be the access points, the switches, everything along those lines. And it's worthwhile, again, setting this to something, and you can use this later on. So I'm actually setting it to the same as my admin username and password. It is only used if you need to log into those devices individually, which you shouldn't have to. If you do have a problem, you normally just factory reset them. And reset, you can then re-adopt them and add them to it. In this scenario, we're going to choose home. So some of this is always going to be different for each one of us as we do it. Maybe I had to put a dot, there we go. So it's already found this router. I'm going to not add that in just now because I want to be able to get all the way through to setting this up. So I will add that in a little bit later because we will then need to override these settings in due course. So I'm just going to check. Actually, in fact, what we're going to do is we will set this up right from the beginning because it is the router. So we're going to choose this device. We're going to go forward to next. If you do not have an Omada gateway or Omada gateway has been configured with WAN settings, skip this. WAN setting overrides. All right, so if you do not have an Omada gateway or your Omada gateway has been configured with WAN settings, please skip this setup. With WAN setting overrides disabled, the WAN setting of the newly adopted Omada gateway in standalone mode will take effect on the controller. When the WAN setting overrides is turned on, the gateway will use the configurations on the controller after adoption. Please make sure the configurations are correct. So I want to set this up correctly in the way that we want this to do. So we just need to see what we've got. We've got a 706 by the looks of it. So it'll be this one here. It's up to us what WAN ports and everything else. So this is standard. So what we're now doing is, because at the moment this has some basic settings in it, when we adopt it, we actually want the controller to manage all of those settings. So this is a little bit tricky when you do this, when you're now setting up a new Omada router in this setup. So we just want to make sure that this goes through correctly. So we've got normal WAN, SFP WAN is a faster or a transceiver port that you can have in there. But at this moment in time, all we need to worry about is the WAN. We can see it's on dynamic. It's going to pick up an automatic IP address. If you're using different one of these, sometimes NBN has this, then you might need to change that. This is all correct and as it should be. I just want to see, why is it not allowing us to move? Everybody's probably screaming at me saying, I can see it. Oh, I think we just need to apply this on here. So that's applied. This connection is correct. You can obviously turn off if you don't want that other port to be used. So let's choose next. And we'll actually just see what is going to happen in this way. It's wanting to know if we're going to configure Wi-Fi. Oh, I just need to scroll up. So we're going to call this TTG Spinel. I'm going to put a password on there. And I want to show you later on how to optimize this to get the best speed out of it as well. So here we've got the controller name is 4G test. This is the name of our site. We've set up the internet connection how we actually want it to be, and this controller is going to manage it. And we're now going to hit finish. So I'm not sure whether this is going to actually be able to adopt the controller because we did set a password for it. So it'll be interesting to see if it actually needs a password to be put in to actually join that to the network. So the controller is set up. So we obviously gave this a name of TTG. So we'll just let that log in. Okay, so now at this stage, it's just trying to give us some basic ideas of what we can actually see in the system and how it's all controlled. And some of that we'll be learning, but this at least gives you an idea as I walk through how to actually get everything set up. So I want to just see if it actually has added in. There's a new controller version, which we can probably update to in a few moments. At the moment, the gateway doesn't look like it's adopted, so that will be the first thing that we're going to get done. We've got our site here, so we can now go into our site, and our site is actually going to show us any devices that have been seen, and we might now need to actually do an update on the controller before we'll actually be able to do other bits and pieces with it. But let's just have a look and see whether it can see that there are any things in here. So this hasn't actually adopted our router yet. So what I'm actually going to do is we're actually going to do that firmware update. And once we've done that firmware update, if I can find where it is now, because it was under notifications, wasn't it? Let me just see, was it under notifications? Was notifications here? Let's just come back up to the dashboard. We just need to do that update. Okay, so we just need to go, let me just show you, you need to just go back up to global. You can just see under there, and that will just prompt you for the settings in here to be able to update this. So I'm just going to push this on. There will probably be several other updates on this as we go along, because I think we're at time of recording, we're about 5.15. So let's just run this through. We're just going to let this do a update, which will just take a few moments, and then I'll actually join back once that's actually done. Okay, so as we can see, it's now downloaded. It's just now applying the update to the controller. So we should be able to go back through in a few moments and actually add in the router. The more tricky bit of this journey is probably actually adding the router in, or my opinion. There are many ways of doing it, but adding the router in that first time that we actually do this to get everything neatly running. Once that's in, we're going to change the IP range. So it's going to be something that's not going to be conflicting with anything or any other broadband connection that you have. That's probably the second trickiest thing to do. Once we've done that, everything should become a little bit smoother in operation. And from that point forward, we should then be able to actually start doing the rest of the config and get everything ready. That's why it's easier to have a computer now connected to the local side of this device, because it means that we're not reliant on the internet connection, everything else working for this, other than obviously doing the update. We did need the internet for that, but past that, we don't really need the internet for this initial bit of configuration, getting everything running. So it's applied part of the update, but this would be fairly normal. It means that the device has gone into a reboot, and this key here will no longer be functioning because it's reset itself. So don't panic if you see a 404 error like that. It's just a matter of the fact that it's restarting and its unique security key will have changed. So just reload at that point the web browser with the original IP address that you have, and that will then allow us to see this to start up. Now, all of this bit, as you can see, is moderately slow. So do be patient. It does tell you what's on the front of the screen. It is running a little operating system. It isn't the fastest in the world, but it doesn't need to be because it's not your router or anything. This is actually just controlling what is happening here. So it's almost at the point where it has now started up and we should be able to log in again. We'll then just be able to see whether there are any more updates, and we should now be able to then get the router all in line and set up that way round. So hopefully let's just see if this is going to work. This now should hopefully allow us to log in again. All right, so again, our username and password that we set. All right, it's just waking itself up after that first reload and update. And here we are back into our controller. Like I said, at the time of recording this, so it is February 2025. It has actually updated I think it's updated it to the most recent version that we have here. There should be a way to see that in due course, and we'll have a little look, but 5.15 is the current version. So what we're actually going to do, like we've done before, we can go into the site here. we want to try and see if we can get our gateway adopted and correct. Now, because I went through to get our IP address, it wasn't in factory default. And because it's not in factory default, then we set a username and password. So we will need to have that username and password to then be able to adopt the device into the network. If you did it in factory default, then this would probably already be in at this point in time. So let's just see if we can go now to devices. Devices should show us this as, I think, pending. Last time we actually had a little look, or no devices found at this moment in time, which is interesting because there are a number of devices actually connected to it. So a little bit interesting there, probably because this device has rebooted recently. And as a result, the other devices in here haven't been seen because they haven't tried to look back or look home yet. Let's just check in global, that in global it doesn't give us any other options here. And that's why I record these videos this way around, because there isn't a perfect science. You think that everything is working fine, and then you suddenly find that for some reason it doesn't show you a bunch of the devices here. So it has seen these, it just doesn't know what actually to do with them. So all I went up was the global view. So let's just have a little look on here. Action for us, adopt. Please accept the site. We want to put this into Spinel. So I think this will probably, for the router, ask if the gateway is a different model from the gateway model configured. Please go to wired and change your gateway model. Please choose university as the gateway when your device is not listed. Okay, so that's because of how we set it in the beginning. So we're going to do exactly what it says. So we're going to go to settings and wired connections, I think it is, settings. Settings. Oh, I think we have to do this in Spinel. So we change to Spinel. All right, so we've got some more controller software available if we decide to upgrade to that. So because this is new, it's probably worthwhile doing. That's going to take a little bit of time, but let's first go and find our settings so that we know we've got this right. Wired networks, internet. We've got our overrides. Oh, look, here we go. So we have our, let's see if we got our 4G model. I'm not totally sure which one we've got. So let's go and actually have a look in here, the status. Hopefully this might show us in system status the actual model it is. Let's log back in again. So it does want it, and that's why the firmware needed to be updated. So we've got a version 1 here. All right, so we need to just match this up now to be version 1. Okay, and we should now be able to set that correctly, which was all the settings that we wanted. Drag the internet connection, drag the current WAN port to the field to copy its settings into the new port. Okay, so we need to push this one in here, and does this one allow it to go in here as well? I think we want those settings to be in there by the looks of it. It's just because obviously it's changed the way it is, and hopefully your device will be slightly more up to date than mine when you come to do this. So now it is all in place. That's actually moved over. Now in my instance, I don't need WAN 2, I don't need that to be enabled, but this one should be correct. I'm just going to have a double check of the settings. It's picking up a dynamic IP address, which is all I actually need it to be able to do to function. So I'm not going to update this controller just yet. We'll do all that a little bit later on. All right, so again, I think if we come into devices, these devices are now showing here. It just took a moment to update. That's okay, we're going to deal with that one in a minute. Let's just deal with this one. We want to adopt this. So here's the device. Hopefully we can now choose adopt. This is adding it to our OC controller. I know this takes a little bit, so it said the username and password is incorrect, which is what we expected it to be. I just need to figure out if there is a way for us to be able to put in the username and password. Here we go. So the username we set up in the beginning, it's because it needs to actually log into this device and now make some changes. So this should now adopt the device, and this will actually bring it into our network, and it's now manageable. So this, I guess, is the slightly more difficult setup initial bits that we do with anything like this, any cloud managed solution. And once we've got this foundation right, then we're all good from that point moving forward. So now it's provisioning it from here. So it knows of all the settings that we've got, and it's bringing those across. We will in a moment go and change the IP addresses, but we'll do that in a process. So we're just going to give that a couple more moments now to update and finish the provisioning. And now it's gone to connected. All right, so this device is now part of our Omada controller, and it's actually now managed by the controller and not itself. So I think if we actually were to try and log in, it tells us this gateway is now managed by a controller, and we can no longer manage it directly in there. We can make all the setting changes and everything that we want from within side our setup here, which is great. It's a really great and easy way of making this all work, and how the network's all done, what the ports are actually doing, and if we want to make any changes to those ports as well. So this is how we are set up. Let's just prove to ourselves that we can still get to the internet, which we can't, which was interesting because this is where actually my LAN connection is plugged in. And so no longer can this, I think, connect to the internet because it's expecting it to be plugged a different way around. And that is because of the way that we did that adopting. So let's just see if we can change how some of this works. And so we need to come over here to settings now that this is provisioned up, and go back to our wired networks, which evidently I've made a mistake in. And so we've got here our WAN and LAN 1. So let's just have a look and see what we've actually got wrong in this setup. I'm not sure why WAN 2 is in here, because we've got LTE running. So let's just have a check on our IP config. So if you have this issue, we're just going to check out, we've got our IPs. And there we go. So it was taking a moment for the router to come online and update, which panicked me. So I couldn't quite figure out what I'd actually done wrong. So that is set up exactly how we need it to, and it's now functioning. If we come to devices, we can actually see it in here connected and working. All right, so if we want to, we can have a look at some of the rest of it. This switch type is inconsistent with the switch type configured for the site. Don't quite actually know what that means, but I would like to actually bring this switch into the network as well. So let's just see why it doesn't like the configuration or the way that this is actually configured up. The switch type is inconsistent with the switch type configured for the site. All right, well, we might have to come back and have a little look and see what we've spotted on that. But I want to just show you the next main bit, which is how we change the IP address and therefore get this moved to an IP that won't maybe conflict with your internet service provider. You might not need to do this step, so do feel free to run past it. What I do want to do first is I do actually want to look at the way that the device is actually configured. So I'm going to come back to global, and I'm going to join this to our TP-Link cloud account. This means that I can find out IP address information and other bits and pieces without actually having to know what's going on the network, because I'm about to change its IP address. It's probably one of the most useful things that I can actually do. So cloud access is where we're going to do this. We're going to enable cloud access, and it's going to ask for our ID. In this instance, Oops, can't even do that right. Okay, so that is our username. So let me just grab the password here. I'm just going to grab from our password manager. So this is now connected to this address here. So if we head on over actually to on-premise, you'll see in here a number of devices we have. For customers, we can see the version status, and then we can actually access the unit directly. We could do this as if we were actually in front of it and connected. This is useful because in a moment we're going to change the IP address and we won't know what it's going to change to. So we can actually use this to get back into the unit, and anywhere that, as long as this has got internet access, this will able to actually then call home. So now we've added this, we can actually go and change this IP range back to something that is not going to conflict with any other ISP or router that you might have into your network. So we can head up into Spinel, which is our site, and we're wanting to head into wired networks because we're going to change the local area network, the LAN side of things. So in wired networks, we're going to go to LAN, and here we're going to change it to an IP range. We can see this is our current IP range. We want to change this away. Now the switch that we have connected will change its IP, the gateway will change its IP, and the OC controller. The problem is that those type of things happen over a period of time. If the network cable is physically not reconnected, it can maybe sit for about 8 hours. So we'll get internet access, but these devices won't. So in a moment, we'll actually go and restart those because that will actually be a quicker way of getting them to get a new IP address. So we're going to just choose a subnet that's completely different to anything else that's running on here. So .14. So we need to now change the DHCP scope, and I like to just make this have a little bit of space in case we ever needed dedicated IPs or static IPs. So I'm just going to change that to .10 there, and I'm just going to change this one over here to .50. Well, this is still going to give us, as you can see, it doesn't want to do this. This is still going to give us 240 usable IP addresses, which is ample. You might need to change this. If you think you're going to have more devices on that, you can change this. You could use the update range to do it automatically. I've done this manually. Now, when we click save, this is going to say, I'm going to change all of the settings. Are you really, really sure? So I'm going to hit confirm. You could have done this through the controller up here that we did. This takes a few more moments for it to be pushed to the device. For this initial stage, I'm just going to do it from here. So I'm just going to hit confirm. If we were to come back to our command prompt, let's just clear out what we had in here and go back to that one that we had before, which was ping. We'll actually see that we now actually can't connect to the internet. Why? Because if we look at our IP address here is actually still in the 0 range, where we've changed it to 14. So for a computer, it's pretty easy. We can just do a renew of our IP config. By doing this renew, we should pick up a new IP address. It does sometimes take a little while to update, but if we now do this, we can actually see we're in a 14 IP range. So if we again ping Google, we can see we've now got internet access. The problem we don't know is what IP address the OC controller is on. And it'll actually probably most likely still be on the old IP address. So we have a few ways of doing it. The easiest way really is just to reboot the OC controller and the switch, and then that will force those to pick up a new IP address. For speed, that's the way that I'm actually going to do that. So let's just head on over to our setup there and just show you that happening. All right, so as you're aware, the OC controller is powered by our little PoE switch here. So the easiest thing for me is actually just to pull the power out of the back of that device and then give it a moment and plug it back in. What's that actually going to do? It's actually going to reboot the OC controller. It's going to put new power to that. This is always going to connect back to the router again and request a new IP address as well. So we can just wait for a moment. We can see the power light has just come up on there on our controller, and our switch there is comfortably booting as well. All right, so let's just walk back to the computer. It will take a couple of moments for those to actually come back good and finish booting. But over here, again, part of our problem is we don't actually know what the IP address is of the OC controller. We won't be able to reload this because this unique key up here links back to the IP address that it used to have. So what we're going to use our on-premise option in our TP-Link cloud. We're just going to hit refresh, and we'll find in a moment that this will probably actually show as offline. So let's just give that a couple more minutes to start, and then we'll come back to this. Okay, so it took about 3 minutes or so, and we can now see this is online, and we can actually log into this. We can actually find the IP address directly from here, from the controller of what it is, and then log into it locally again, which we'll do in a moment, just to make things a little bit faster. But this is our sort of a get out of jail free card and a way round of actually making it work. Like I said, you don't have to do this if you found that if you found the IP range doesn't conflict with anything that you've got working. But I just wanted to show you this as a ultimate way round it. Now, it's just having a little bit of an issue by the looks of it, finishing off connecting. I think it's not quite booted yet. So we'll just wait for that to finish there. But while it's doing that, what I just want to show you is a quick speed test of the connection, just so you can see as a standard router what sort of speed you can get through it. So we run something called WebPerf, which is on a 10 gig test server. So let me just go into that folder. So what this is going to do is a speed test with 5 concurrent streams to our test server. And you can see there we're getting 866, 870 megabits a second. So that is really performing. If you've got a 1 gig internet connection, this router itself is giving you 1 gig. We'll try and show you what you can get potentially on wireless as some of the next stages once we've got this working. But I just wanted to show you what you should be able to assume that you can get from this device as well. It obviously is a small little router, and it only has a 1 gig internet interface. So getting this is actually pretty cool. Hopefully that's a good, useful show of some speed there. And we'll do some more when it comes to wireless shortly. So let's just see if we can get into this device. It's just taking a little while here to do this. Like I said, I think it's just because it has been finishing booting. That's just because I'm an impatient person. Just come back and launch the connection brand new and afresh. Here we go. That one I think probably is going to load a little bit easier. And we can use the client's view over on the left hand side here once it has loaded to be able to find the IP address of the controller, and then we'll be able to make some management changes directly in that as we start to work on the next portions of the setup. So as it just loads, like I said, we can get to this. We can go to clients on the left hand menu. We first need to come down to the site that we want to be in. So let's just head to that site on the left hand side, site top right hand there. And then in a moment, it'll just give us a few extra options down here, and we'll see client in a minute. This one here, clients, and we're looking for our OC controller in there. Here's our OC controller, and it's on .12. So if we go back up here and change our IP address to 14.12, we should now be able to get into the local controller. Don't worry about that. Doesn't mean it isn't insecure. It just means it doesn't have a paid for certificate. So it is still as secure as it needs to be. We should now be prompted to actually log into this device. Here we go. So let's log in. Okay, so we're now back in. We've performed an IP change. We've probably done all the most difficult portions of this now. So what we really want to start on, other than clicking all these boxes that are sort of slightly annoying, and there are some options there with the firmware upgrade for some of the devices. We do probably want to get that switch set up into the network. We did have some issues before that it wasn't happy, because every device that we've added, if it has the word Omada in it, when you purchase it, you can manage it here from the same controller. So let's just have a little look. It did have a red exclamation mark on it before, saying it wasn't in quite the same setup or switch configuration here. So I did notice, I think, when we went into settings previously and wired networks and the LAN, there was a switch profile option up here. Let's just have a little look. I'm not sure what it has. So it's got all keep devices settings, okay, switch settings. So everything there looks like it shouldn't be an issue. I'm just not quite sure why it's not happy with that. So I would like to just quickly crack why we can't add that in. So let's just choose, it does have the switch does not match the switch type configured for this site. All right, so let's just try and see again what that switch type is and see where we have the issues. So just bear with me 2 minutes while I just find the answer for that. Okay, I've not actually come up against this issue before where it says the type does not match. And this I found out is actually related to options for how you manage or what devices can be added into your setup. So you want to be in global view, and you then want to edit the site. So if we come up to the dashboard in the global view, we can see our site is here and we can choose edit. What I've not ticked in this instance is allowing us to also have easy managed switches. These don't support all of the functions, but they do what we need them to do. In this instance, it's just providing PoE. So I forgot to actually tick that box. So should be now that if we go back to global, or back to our spinel view, we can now actually get that added in and adopted, and then I'm happy that we can move on from there. So let's just go into devices, and now it says that it's possible. It doesn't have that exclamation mark. Let's just get that adopted and provisioned. So we've now got our device in place, our router, our switch and our OC controller, and we've figured out a few little problems that we had along the way. Most of these are updated most of the way along, but we have some firmware updates we can do in due course. So this is now added and we can start to move on. So having got that bit done, we just want to look at wireless and get the best out of it. We saw we could get a gigabit a second from the Ethernet port. It is slightly different on what we're going to get straight from the internet. So I'm just going to quickly connect my mobile phone up to the wireless of this device and just do a speed test using iPerf again, just for reference so that we can see what this actually does. So let me just run a speed test in the standard setup. You can see there we're getting about 400, just under 400, maxing maybe sometimes around about the 500 megabits a second. Now, wireless is all driven by the number of channels that you join together, if you like, and each frequency has a maximum number that you can join. And the more that we join, the faster speed we can get, but at the same time, the devices need to be closer, and there's more interference from other people around or neighbors and things like that as well. So in this instance, what we can do, and it's done per device, we can change the channel width. So if I actually now go to our router, because remember we've got an AX3000, mentioned it before, that can do about 600 megabits a second in the wireless in 2.4 and then probably 2.4 gigabits a second in the 5 and 6 gigahertz frequency. Now that's your synchronization speed. You'll then get roughly half of that speed. So in 2.4, if you synced at 600 meg, you'll get around about 300 meg a second. So we're wanting to get ourselves to sync at close to a gig to give us 500 megasecond, and depending on the quality of your device, you may be able to connect faster than that. So we've gone into the device and gone to config, come down here to radios, and we can now change the channel width. It's on auto, and probably for most people, leaving on auto is the best. If you're trying to get the most out of it, then you can play with this depending on which access points you've got. We can only change this to 2.4 and 5 because wireless, the 6 gigahertz frequency is not supported on this router. So let's choose 5 gigahertz. Use the maximum number of channels. So this is 8 channels joined together, and we're going to apply that. Now what I do need to do is I do need to just disconnect from the Wi-Fi and rejoin the Wi-Fi, just so that I can tell the device to resynchronize. So let me just do that on here. Let me just do that on here. All right, and let it reconnect. And then we'll just do another speed test and just see whether we've got a little bit of improvement as a result of making that test. Okay, so let's run that test again. And it does take a few moments for my device to resynchronize and join the Wi-Fi again. So let's just give that a moment, and let me just give that a moment to reset. Okay, so we've just rejoined the Wi-Fi. It took a little bit of messing around to get it rejoined and give it a moment. But you can now see that our speed is above. Now, it depends on where I put my mobile phone exactly, but you did see it spiked up to 694 megabits a second, which is, again, a good 150 megabits a second faster than we had before. We're consuming more channels. We're meaning the device has to be closer, but we can see greater speed. So realistically, this device should be syncing at probably close to a gig. So we can have an hour look if we want to see that and go to clients. And clients, you can add some of the missing columns if you want to in here. And you can see what my dB level is. I'm actually in pretty good here. You can see that I've actually connected at 1.2 gigabits a second. So as I said to you, you get about half of that as an actual transmission speed. And you can see here, I've even here connected at 2.4 gigabits, which is the maximum it is. So now some of this speed is down to the wireless of the device that's actually doing it, the wireless in my phone, and all of the quality that is around that. So depending on your distance and the quality, we can see that it is potentially possible to get up to close to that gig a second. I reckon the high 600s or 700s is probably the speed that you're going to generally get. So hopefully that's a start now. We've done our controller, we've got our router online, and we've got our switch connected. We've talked a little bit about Wi-Fi. I'm just going to quickly go back and change that back down to auto for the moment. Sorry, I need to do that in devices because I just want to make sure that we don't oversaturate what we're doing in the rest of the test. And you can obviously do that per access point if you want to. So if there's some areas you want to get a little bit better performance from, then you could boost that up if you knew there was devices that were generally fairly close. So now I think what we really want to do is head on over and talk about the next bit in this to actually get the wireless access point connected, and then we'll have a look at the features that we've got on that as well. So let's head on over there. Okay, so obviously we've got all of our bits and pieces set up as they are. We want to add in this access point. Now this access point is actually an AX1800, so it will do a slightly less of the speed that we've maybe got off this router down here, but that's okay. We want to just make sure that this actually functions and works. And so this would be, maybe we're going to extend this inside. This is still going to give us 500 or 600 megabits a second. So what are we going to do? Very easy. This is PoE powered, single port in. There was a power pack in there if you wanted to prefer to put this to a mains. Often just think about, I know wireless does come out around this, but it is designed to be ceiling mounted and more the traffic to come in a sort of dome, if you like, underneath that, if I was to put it this way out. So just think about that as you put it in place. So all I'm going to do is I'm just going to connect a cable up to this device here and plug it in to one of those spare Ethernet ports that gives out PoE here in our switch. And that will allow that to power up. And once that's all powered up, we'll be actually able to adopt that in exactly the same way as we were able to do the switch and the router, or the switch and the router. And then we should be able to do a little bit more wireless config with that. And then we'll maybe look at some of the other options around what we can do with wireless, and then we'll extend it out to the next building, just using this bench here, and we'll be able to see how those bits happen as well. So after a couple of minutes, we can see the device has booted. You can just see it here. It's actually blue. It's faded out with the lights that we've got here, but it's a blue indicator light here to show that this unit is all started up. So now if we head on over to the computer, we should be able to adopt this and get this set up into the network that we've already created. Okay, we've done all the heavy lifting really early on in the stage of this. And so this makes this portion really quick and easy for us, because all the devices, certainly wireless ones that we choose to add now, they will going to pick up all those wireless settings that we've already created. So we can just choose this and choose the adopt. This is going to add it into the network. It's going to add on all of those wireless settings. And we're actually going to be ready to go at that point in time. That's all there is to actually adding another network access point. These are set in a mesh. In this terminology of mesh, I mean a single network name, an SSID, being shared across all of the access points that are physically cabled to each other. So if we were actually to go into this device, we could do this again the same as I showed you on the router itself. If we went into radios on this, we could again change the channel bandwidth if we wanted to improve the bandwidth. You'll see, because this is only an AX1800, that we can't push the bandwidth up, the channel width, more than 80 megahertz, whereas on the AX3000 router up here, we could push that up to 160 megahertz. My phone will now, or whatever device is being connected to my phone, will now jump between whichever connection it finds more appropriate and is closer. And so that's how this works. So we want to try and get our density right. More of these spread across is going to give a better footprint. It's going to mean that devices are not as far away as they should be, or not too far away, sorry. And so as a result, our wireless is going to be good for everybody. Because remember, if another device has a lower speed, it is going to help, it's going to actually draw down the speed for everybody else. So by getting enough access points spread around our house or our property or office or whatever we're doing with setup, will allow us to get the best balance that we want from all of this. So that is the simple stage of adding another wireless access point to this setting and this setup. It just is adopted in, and all of those settings are there. Now, you may decide, if you're going to have multiple access points, that you do want to look at WAN optimization. Because we talked about channels and these can overlap each other, optimization is a useful thing to do. What does this do? This actually makes sure that all of the devices are not overlapping with their channels. And so as a result, we're going to get the maximum performance from each of those devices. This will often run on a schedule and will reinitiate, because this can be affected by your neighbor's devices and things like that as well. So you can customize this a little bit further in the settings if you want to make a whole load of changes yourself to be very specific. But often just the general optimization will give you the right balance that's there. So I'm going to let that do that. I'm going to go and grab a 4G SIM, and then we're going to actually put the 4G side of this router in place, and then we'll start connecting up to one of the other buildings. Okay, so you can see that the optimization is now complete. It feels that it's got a 39% increase in what it's done. It will have changed some of them to have some slightly different channels. You can see these have changed so they don't cross over, because we've now got these two access points. And we're going to get a better user experience. So the more access points you add, the optimization becomes quite useful and important to do. So what we're now going to do, like I said, was going to head over and we're going to try and see what we can do in the 4G side of things and get the LTE running. So let's have a little look in this device here. And I believe at the moment, when we look at here, I can't remember where I'd seen it originally, LTE it shows as not being online. So let's just have a little look. I'm not sure we had any other settings over here. But once we get this actually up and running, we should be able to see, I think something should come online here. hopefully. Let's just have a little look in LTE. Here we go. And we probably want to set this ready on here. So I'm going to turn data roaming on. We've got 4G only. I don't think we are not going to have an issue here because 3G doesn't exist anymore. All right, so let's just apply that. Let's head on over to the workbench there, and let's get the set up, because this should all be automatic, so this should hopefully fit together pretty easily and simply. All right, so I have got a SIM here. I think the one that we need is the smallest. I'm just taking this out of its casing. It's from a multi SIM, so I'm just going to pop out the card that we need. I might need to just put my glasses on so I can at least see what I'm doing. So let me just pop those on. Let's just move our controller out of the way. It didn't have to be on top of that. Let's just turn this up so we can actually have a little look here. This is our slot in here that we actually want to put it in, and I've just taken out the core piece of that. Wanted to try and mirror, by the looks of it, the image that's there. So I'm hoping that that's the right way round, never quite sure. Right, so that looks like it should be in. I don't know whether the unit has to be off before we plug that actually in. Nothing's actually come on here to suggest that it's doing anything. I'm hoping that I have. Oh, there we go. So we can do this live. I'm presuming this is starting to go through its boot sequence, and we're getting a single signal strength there. We can see LTE has come on to show that we've actually plugged that in. So I don't know whether this will now go through and find the APN, the wireless access point to connect to, if you like, or the 4G connect to. So let's just pop that down on the bench there, head back on over to our computer, and actually just try and see whether we see anything in the stats or the information about this. So having a look inside here, obviously we turn data roaming on. I presume that we maybe have to go back into devices. Let's have a little look at the device here now. This looks, let me just have a little look. I don't know whether this is that. Let's just have a look. So ports, I don't think LTE is actually now showing something. I don't think we maybe are going to see anything more. Statistics might give us something useful. Let's just see. So I'm sort of doing this as a rough estimate. I've not actually done this in this device before, which is why I thought I'd actually record what we're doing here. So I really want to just see if somewhere in here LTE will be shown, so we can at least get some statistics. Okay, so I had missed a very simple thing. If I go to details, scroll down, LTE here, it actually gives us some information of what's going on, and we can see we've picked up IP addresses. We can see we're online. We can see that with Telstra, the SIM's enabled. It's saying that we've got a fairly weak signal. My location here isn't super great, so probably not expecting anything to be fantastic here, but it will at least give us something to check that everything's working. Now, I guess the solution that we want to first start out with is if I was to do what we've done before, so it's a ping, and we're going to get a ping going to Google. So we can see at the moment we've got 14 milliseconds going out over broadband. It's going out pretty easily. I guess what we should go and now do and see whether there are any options for failover. So let's just go and have a look at our wired connections. It might not be in here. I'm looking for options around load balancing or failover. And so let's just have a little look. This is, I don't know what the line backup. The line backup sort of sounds like what I would expect it to be. But I think first, online detection results, we're looking for whether load balancing and link backup features are. The smaller the online detail. Right, so what we have is an online detection interval. So it's going to detect, by the looks of it, every 10 seconds if there is an internet connection. So we could reduce that down if we wanted to in length. And that would then let us know whether it was actually going to fail over more quickly. So I think that this, go to edit the state of the gateway port, so let's just check that we've got everything that we want in the way that we think it should happen. I don't know whether there was a LAN or load balancing section, so there might be. We're going to have a look at that in a moment. Right, I think I'm going to have a look a little bit more in depth and see if there's load balancing if we have enough time a bit later on in the video. What I want to just try and see to start with is, can we just do a failover with this? So I've got a ping going to the internet. Like I said, this is going over our broadband because we've got 14 milliseconds. So let's just quickly head on over and remove that WAN cable. So let's just remove this green cable from the connection there. And let's have a look and see what happens. So we can see here that we have dropped the connection, but it has taken just a few seconds, took quicker than the 10 seconds, but you can see now our millisecond there has increased. It is jumped up to 63, so we actually know that we're on a Telstra connection, or we know we're on a mobile connection. So this router is now running just on 4G. So that's what would happen. You just lost 2 pings. So 2 milliseconds is all that we really lost, probably 2 seconds. We actually lost between our main internet connection dropping and this taking over. You would still be able to manage the unit remotely because it now has an internet connection. So that's a really, really great feature, and that's one of the reasons why I wanted to set this up for the client, because I wanted to just have a simple, easy failover solution. So let's just go and switch it back and see what happens. So we're just going to plug that cable back in. I'm not sure how long it will actually take to make the change, and some of the sessions will take, I would have thought, a few seconds to come back. So in fact, it's actually chosen to put me back straight away. Now it's detected that the other connection is online. So coming back looks like it does take a few more seconds, but there we go. Again, 4 or 5 seconds and we've transitioned back. So we've got a very simple, easy failover solution there and working. So that's probably, if you like, what I'll want to do at that start bit of the house. We've done the router, we've done some speed tests, we've done some wireless speed tests, and now I want to just look at, we've got an outdoor access point to add, which is going to be super simple. I've shown you how to add one already. We're going to add the desktop unit as well, but we're going to add that probably when we get to the other end of the bridge, so you can see how all of that works as well. So let's add on our outdoor access point, adopt that. Again, that will bring all of the same config across it. Same performance, same settings, being able to do the channel bandwidth and everything else that I've shown you. So let's just head on back to the bench, get that connected up, and then we'll be able to adopt that into this setup as well. So let me just move this ready for devices, because in a few moments, once it's connected, you'll actually see it appear in here as well. All right, so we obviously are starting to run out of ports on here. We've got 4 PoE ports, so we're doing pretty well. We've got this one access point here running. We want to add in our slightly bigger now outdoor access point. This is more rated for outside. There's a bung that goes in here and completely seals this in place. This again, you can mount outside. It should give you 360 degrees, but again, how you mount this, you are going to have probably a wall or something else behind it. So as a result, I would again think of wireless coming out from here. So this is going to now give the customer wireless in an outside space, but we can set this up in exactly the same way as we've done with this. Super simple and easy to do. Let me just move those out of the way. We're going to take another Ethernet cable, just going to plug that into there. And again, we're going to bring that into one of the spare Ethernet ports in our PoE switch. Remember, we've got 65 watts of power in there, which has got ample for what we need. You can actually now see probably just under the lights, there's a light here that's come on green. So we can see that that's starting to receive power. And we are ready to go. So this was the slightly different access point. This was an AX1800 Outdoor, so these two match, but you can mix and match where you want the best speed or you want the best coverage. So again, you're comfortably going to get several hundred megasecond out of this. So let's head on back to the computer. And you can see that this is now just starting to flash as it gets internet connection. But let's head back to the computer. We'll be able to adopt that, and then we'll be able to start thinking about how to build a mesh and build this out so it extends to another property. All right, so you can see after a few moments, as we've come back to the desk here, that our access point is sitting here ready for adoption. I did just lose some connectivity to the controller for a little bit. Not sure whether that was just a blip or whether it was just the increased power. While that's just adopting, so all I did was clicked on adopt. Remember, this is just going to push all your same wireless settings to it. So if you wanted multiple wireless names, you can do. You're just going to go to wireless networks where we did WLAN, and you can just create a whole brand new network up here if you want to, and just step through a different network name, and you could have 2 or 3 of those. Wouldn't recommend you go beyond 4, but it is possible to go that far. What I'd just like to do is see if we get any information here, statistics from our little network switch. All right, so we are quite close on the power usage, which is possibly why we had a little blip there. You can see it's got a total of 58, it's using 58 watts of its 65, so it is actually quite close on there to the amount of power it's actually using. I'm not sure whether we can see on here how much power. So we've not got too many. There's only got 3 or so watts of what it can detect on there, but certainly on boot up it obviously used a little bit more. So now our outdoor access point is set up here and running, as simple as that. There's nothing else more to do. Obviously we could use that WAN optimization if we wanted to, just to tidy things up a little bit more. So we now want to take this to the next stage, which is the next stage is to start to create a wireless bridge. We want to join 2 buildings together. The great benefit of, again, keeping this all in the system here is that you've got one central place to manage it, one set of network names, and it's simple for devices then to move from one location to the other. I'm going to be using a bridge kit called the EAP215. So let me just wander over and I'll just show you a little bit about that over at the desk there. Okay, so make a bit of space here. We've got our outdoor access point, we've got our indoor access point running, we've got our controller, we've got our small switch with 1 port left, and we've got our 4G router as well. So what we want to now do is then extend this using these EAP215s as if we were going to run this out to another building. Where I'm actually setting this up so it can run out to the customers, whatever you want to call it. It's a cabin, a Donga, another area that they actually work in. So we're going to use these 2 devices that are already paired together. These are slightly different. These are 24 volt powered, so we can't power them directly from the switch. We're going to use a PoE injector, and we're going to connect one of these up. These can probably do about 1 kilometer. They also do give you outside Wi-Fi at the same location. It's only in the 5 gigahertz band. So it's okay for mobile phones and laptops, but probably no good if you've got smart light bulbs, potentially some solar panel arrays and things like that as well. So do be aware of that. So let's just start working through how we get this connected up. So we're going to be using a PoE injector. What is a PoE injector? It takes power from one side and your Ethernet or your LAN or your internet connection on the other and mixes it together, and out of the PoE port comes an Ethernet cable that now carries power and data. So let's get this connected to the mains. Normally you're going to plug this in probably where your router is, all right, because the great thing is that that PoE port out, that can run up to 100 meter Ethernet cable quite comfortably, and so that is going to work. So this can be inside with your router, and then all you've got to run is an Ethernet cable out to that location. So into my LAN port here, I'm just going to use this and connect this into the 1 spare port that we've got left on our network switch there. Now that is a PoE port, but in this instance the device is not asking for PoE power, so it won't deliver it. So it's quite safe to do it that way round. I'm then going to plug another cable here into the PoE port, and this would be our long cable that runs all the way out to the outside of the building. Like I said, these 2 devices will cover up to maybe about 1 kilometer, but please, there shouldn't be dense trees or other buildings in the way, or you will have problems. So we can open up the bottom of this. We've got 12 volt in on this side. So there's 12 volt if you want to. That could be powered from a solar array or a battery directly. We've also got a LAN PoE Ethernet port in there, which is what we're going to plug in. And you can see now that our PoE injector has sent power, and this is now starting to spin itself up. I'm just going to put this over on this side here out the way, somewhere where we can probably see it. And I'm just going to move this slightly to the side. And the idea is that this is going to be a very short distance, obviously, from this device here. Let's actually bring all of this back a little bit more so we can actually see the final bit of a setup. So this piece here is now being mounted on the outside of our building. And we're going to put another one of these over on this side here. And those are then going to link together over the air, all right? And then we're going to link them back to this nice little desktop access point, which we're going to have in their Donga, in their work cabin. And that will give them not only just some Ethernet ports on this side, but it'll also give them wireless there as well. So I'm just going to grab another 24-volt PoE injector, and then we can get this side connected up as well. Okay, so I've gone and got another PoE injector here, and a couple more cables that allow us to complete this off. So obviously the other end still needs power. I'm going to use the same power board over here, obviously because I don't have another building to show you in this instance. But obviously we're not going to have anything else of the Ethernet, of the network plugged in, as in none of this equipment over here. I know it's getting a little bit messy. So all we're going to be doing is plugging into the PoE port at this end. So just the PoE in here is all we're actually using for the moment. We will use LAN in a little bit. All right, and again, we're just going to open up the bottom of this device. We're going to look for LAN PoE 1 or LAN PoE in there. All right, and again, looking for the lights coming on the outside of that device. Those two are now facing each other. Now, in some instances, in this instance, I've actually used these in a test environment before. So I do actually want to just factory default them. And that's, again, very simple and easy to do. We're just going to put a pin, same as you get for a mobile phone SIM. Hopefully I can reach in there and actually do that. Let's just see whether it is. There you go, I can feel the switch. I'm just going to hold that in there for a few seconds. Hopefully all those lights will come on, and then in a few moments the lights will actually go off. So if you get your config wrong, or you've got these from somebody else, your mate or somebody else like that who's used it, it's easy to add back to a controller. You just want to, again, factory default them, hold it in for about 15 seconds or so, and that will instigate a factory reset of the device. So that one, as you can see, is now resetting. I'm just going to do the same on this other one here, because with doing this, they'll now go and try and look for a new controller. Otherwise, they're still looking for the old controller, and they'll have a username and password that doesn't match up either. So I'm just holding that one in again for probably about 15 seconds. I look for all those lights to come on, and then back down to one light, and now I can set that over there. So we've got our two devices here actually looking at each other. They don't have to be perfect. The better they are aligned over the distance, the better quality signal that you're going to have between those. So at this point in time, that's all configuring. We'll go to the computer in a moment. If you were using these outside, you could potentially wire in, your solar inverter or something directly there if it supported Ethernet. But we want to actually go on to do wireless inside as well. So we can already see the lights have come on the side here to show us that he's actually seen the device at the other end. This one obviously has slightly more lights because it has some of its Ethernet ports connected as well. So let's just leave those there pointing to each other. And we should be able to head to the computer now. And on the computer, we should actually be able to adopt those into the system. And just the same as we've done for all of the other items. And that will be our step one closer to the final bit, which is to add this wireless desktop in at the end location and give wireless down there as well. All right, so as we look here on the computer, we can already see that one of these bridge devices has called home. And so let's set that into the adopting phase. And this will add it in. Remember, this is going to add it in as an outdoor access point as well as the start of all of that. And it's also going to allow it to bridge to the other device. I want to just check in this. I can probably just tell whether this is actually physically connected and I've got the right end on here. So yes, this is the other end. The other end may not have restarted quite yet, or I might need to do a reboot on it because it should appear in here as well to be adopted. So I may just go and have to go and reset it. No, it's there. And it's already seen the other end and it's already now automatically adopting it. So if you think about what we've got in that space, we've actually got two units that are separated by air. All right, but the second unit is now already communicating with the first one. This is a beautiful, easy to use system. And you'll now see once it's provisioned, this has now given us outside Wi-Fi all the way down to our outside office, that Donga. And then we're just going to do our last bit of doing Wi-Fi inside for it as well. And you can see here, this shows that it's wirelessly connected to this device. So we've got down to the building. Realistically, this is so easy. We can now already move with inside the house and use the different, we can use the router's wireless, we can use the wireless access point, the disc-shaped one. We can go outside and we're going to get coverage from the main outdoor access point. We're also going to get it from this bridge as well. But now we want to add in that final device, the device that's sitting right at the other end of the connection. So let's just go back to the workbench and plug that in, all right? And that will be the final stage of getting this project set up for the customer. All right, so we have got every piece of equipment here. This is our air-gapped two devices. These are talking to each other, and again, they can be hundreds of meters apart. So now we want to give Wi-Fi down the other end, because we've got some Wi-Fi outside with this, which is great, but obviously if we've got a metal-shelled building, and remember that wireless doesn't like going through dense material, so a metal-shelled building is not going to be really useful for you. So you do want to actually have an access point inside. It's very easy to do and probably the best thing that you can. This EAP, put it on here, this EAP650-Desktop is superb for this. We've got a small number of Ethernet ports on this side, which means we've got a little switch in that work office to connect the printer or whatever that doesn't support wireless. It's easily powered by 12 volt and it's going to give us really good wireless 6 here as well. So let's just get to plug this all in place. So we've got our PoE injector here, probably got the longest cable that I actually need. So let me just grab a shorter one back again. Right. So our LAN port here, let's just remind us how this has worked. This was probably a longer cable than this. It's going to go out to the outside of the building. This is going to stay inside and it's probably going to be near this device finally. We use just the PoE port. Now we're actually going to use the LAN port of that for the data. And that's going to complete the loop. If we follow that loop round from this device here, it's going to come over and connect to this device here. And that's then going to give our connectivity through to our device here. So let's just plug this into the LAN or the PoE in. We're not going to be using PoE to power that, even though it's connected to a PoE injector. Let me just lay that down, probably is a little bit easier. And we're going to get its power pack. It's a little bit large, so let's just grab its power pack here. All right, so we're going to plug that power pack in. Obviously, I'm using the same power bar for all of the items, but you'd have something else down in your shed or your other location. And we're just going to plug that in, and you can see already, again, blue not great under the white lights of the studio here. But you can see that this is now starting to power up. You can see on here the vents and everything else that you've got on here to keep this cool. We'd probably stand that on the desk like that, just as a neater way of being able to use it. It will wall mount as well, with a nice plate on it. I'm just going to lie that down so you can more just try and see what's happening on there as we go. Probably still will be okay with that even in the line of sight. So this should have been able to talk back through this device, to this device, from this device to the switch, from the switch to the router. That's where it's going to pick up its IP address, and our internet connectivity is going to go all the way down to here. What I'm going to do is I'm going to then assign a separate SSID, only just to show you that it all actually proves and works. But initially when we adopt this device, it's going to have the same network name, SSID, as all of the other wireless devices. And that means I can walk from the house to the Donga, into the Donga, and have Wi-Fi all of the way there. And my phone or my laptop will choose which device it's closest to, which access point it's closest to, and connect to that as I walk through the journey. So let's just hop back to the computer. We should find on the computer that the device has already appeared here ready for adoption. Maybe not, may take a few moments to power up. Let's just have a little look and see. It has not as of yet. Just want to need to just check that I've plugged it into the right port. I think it may have just taken the unit a few moments to power up. There we go. So it has just taken the unit a few moments to power up. It took a little while for me to see the link light appear. So we can see this is on pending. So we can now set this into adopt. Just the same as we've done with all of this. This is so super easy. I know we spent half an hour at the beginning, quite a lot of legwork in that, the heavy lifting, but once it's done, the rest of this system works so beautifully and easily. We can see that this device is in here. We've got so much options over what we can configure. Not going to cover that as part of this video, but that at least should show you a whole bunch of the information in here of where you can actually go and do it. So like I said to you, what I'm actually going to do is I'm going to create a second network. So all of these are now broadcasting the same network. I could browse to it. We could see which device maybe it's connected to the most appropriately that it's got. We can still see that my device, my phone is still connected here to almost a gig a second. So about 500 or 600 megasecond of true speed. So what we can now do is create another network. All right, and we're going to just put this down at here. And we're just going to create a new wireless network, and we're going to just call this Office. Pop this wireless 6. I think because this can support it. Device type, we only just want this to run on the access point because we're going to do down the other end. It can have the same password though, so I don't mind about that. We could enable Milo if we want, or MLO if we wanted to. But probably in our scenario we won't because we haven't got any really wireless 7 devices going. So I've now just enabled this only for the EAPs. This is not going to be applied to the router. So let's just apply that. And now what I really want to do is I just really want to assign this to run only on a specific access point. Now I've not done this before, so you're just going to have to bear with me to just see where I can actually set this, but there should be an option in here to only allow it or to create a group of WLANs. Right, so I can turn my Office off on access points that I don't want it to be broadcasted on. So I don't want it in this instance to be broadcast even, on my outdoor access point. So I'm going to turn it off and apply that. I don't want it to be active on my indoor one in the house. Why am I doing this? Because I want to show you that the connection that we've built actually works all the way down. For most people, they would keep this live on all the access points. But maybe you've got an Airbnb and you want to have a separate SSID down there and don't want to apply it to other items. You don't want them to potentially see that. Then this is another way of doing that. So I'm just going to, again, remove this from the wireless bridge because, again, those bridges were outdoor access points, so I don't want it running on those either. So I'm just slowly working my way all the way up here until I know that everything is, not wrong one, everything is turned off except, there we go, and we'll do it the other way around. I just want to make sure that my Office one I don't think has appeared in here because I think I told it to only be on, there we go, only be on the access points. And now what we want to do is just do this the other way round. And so here on this device here, where we have our WLANs in a moment, I'm going to turn off the other test one that we had and just be left with Office. So now all I've got down at the other end, now look, I've got a load of stuff on the workbench, all crammed together. There's lots of Wi-Fi signals over the top of each other. So probably not always going to be the greatest example of this working totally. But if I run down, I want to just at least show you this is working. So I want to just check, so on my mobile phone, I've just connected to the Office SSID. Let's do this, as you can see. We're just going to run over here and we're just going to do a speed test. So at the moment we're getting 100, maybe close to 100 megasecond. Obviously the bridges aren't necessarily the fastest. Then we've got a lot of Wi-Fi mess that's going on around there. I would expect over the bridges to be, you should be able to get a comfortable 100 megasecond. And that's roughly what we're seeing here. So we've managed to join our internet connection. We've got a 4G SIM in there for failover, which works super well. We've been able to add in an extra access point for the house. We've added in an outdoor access point. We've added in a bridge to get us down to the work office or the Donga. And then we put a desktop device in there to give us Wi-Fi. And at the end of that connection, we've got 100 megasecond. Now, there are plenty of ways of speeding those type of connections up if you want to. There's different equipment that you can put in if you want faster speeds. But this hopefully gives you an idea of what you can do with just a few pieces of equipment. Bit of heavy lifting at the beginning, I know. But once you've got it, this whole thing now runs together super easily and you can add other access points with no problem at all. So I hope you find that useful. Head on over to our YouTube channel. We've got loads more how-to guides, how to set many vendors' products up as well. I hope you found some gold in there. Head on over to our YouTube channel, subscribe and stay up to date.